Hello, my name's Simon Barrowcliffe. I'm the Senior Technical Specialist in the certification team at Element Materials Technology. I'm here today with my colleague Andy Smith, who's the General Manager of our Skelmersdale ATEX Specialist Facility. And we're going to talk to you a little bit about today all things potentially explosive atmosphere. So welcome to that, and welcome Andy.
Thank you. Hello.
Okay. It's a really interesting topic, ATEX, because it's been around for a long time as a CE marking. We're coming up to 30 years anniversary of IECEx, an international thing, surprisingly enough. And by now you would have thought that we wouldn't have to be talking about this, but it's one of those subject areas where the knowledge is very thinly spread across the EX community. So everybody should know about it, shouldn't they?
They should. Yeah, definitely.
But they don't. Go on.
Absolutely
tell us a bit more
not.
about
No. You get varying levels of knowledge across the industry and across the manufacturers that approach us for certification. But there are many who are new to this. They've never seen it before, and it's not that they're new to product design or new to manufacturing. It's that they are new to ATEX or explosive atmospheres. So normally what happens is they'll have an industrial product, there may be an SME, and they've got this product, and somebody comes along and says, now, can you make this for explosive atmospheres?
Yeah.
So that's where the problem starts for them. Okay, so where do we go? And they often come to us as notified body, and I think the first thing that shocks them is the cost.
Yeah.
The cost of getting this certification. So, more often than not, it's not something that's been budgeted for. They're not coming along with any expectations of having to do anything other than maybe just get a certificate for their product, and that's it. But when you start talking about all the testing and all the documentation and so on, that's when it starts to become.
And it's the documentation bit, isn't it, which people I think struggle with. If they've been doing EMC or low voltage directive, the documentation is relatively straightforward. The process is very, very well known, and they come to ATEX, and it's a very regulated process, isn't it? Yeah.
Very much so. Yeah. And getting all the information you need together to get that product through certification, when you've never done it before, is quite an undertaking. And just starting with the documentation alone, you may have drawings for the manufacture of the product, but then not necessarily got the drawings for the certification. I've come across this problem many times before, where a manufacturer has the product manufacturing drawings, but they're not really suitable for certification because they've got far too much detail in there that's going really down into levels of information that we perhaps don't need on the certification, but then also maybe not containing enough information to cover off other areas as well.
And the drawings, I think that's a really important point. Quite often people bring you these packs of drawings, and then they go through the whole certification process, and then at the end they come to make a change to a non-hazardous area critical screw or gasket. And then they have to change their complete drawing set, and then they have to re-engage with their certification body to do it, instead of just limiting the scope of their potentially explosive atmospheres drawings to potentially explosive atmospheres, and leave the rest of it out, because otherwise every change you make you have to keep up and coming back and getting your certificate updated, which is a pain for customers and also for us as certification bodies, to be honest.
Yeah, and it becomes an unnecessary cost as well.
Absolutely.
You don't want to be having to reopen the file and update a certificate when it actually wasn't necessary in the first place. And if you get the certification drawings right at the beginning, cover what you need to, don't cover what you don't need to, and then you're in a much better position going forward. Then you're not having to come back for changes on things that just shouldn't need to have that change done. So but then there's other issues as well. The testing. So you may have you've got this product, and it's being used in industrial applications. It's robust. It's got a degree of protection that's quite high. It's suitable for outdoor locations. It's on the face of it, it looks like an EX product. It looks like it meets everything. But then when you start to think about temperature rise testing and thermal endurance and impact testing and all the things which are really going to test that product against the standards, that's when things can very quickly unravel. You may do the thermal endurance testing and you've had deformation occur, or it's just degraded material, or the seals or whatever, to a point where it just won't meet the requirements of the standards. So that can be where everything begins to unravel quickly, because if you think you have your product and it's meeting the requirements of the industrial application, but now you're having to change the enclosure, now you're having to change the seals, and it's no longer that simple job. It's not just taking that product and getting any.
It's understanding the risk, isn't it? Because particularly for existing product, you know it's okay functionally, but of course as soon as you move that into a potentially explosive atmosphere, it's different levels of risk. And if you're not familiar with that world, then it does become a bit of a shock. Why are you thermally conditioning at this temperature, at that humidity for this long? It's never going to see that. Well, it's never going to see that in its entirety. But this is about product that'll be in the field for 20, 30 years sometimes. And you can't have it go wrong. One explosion and that's it. So it's a difficult concept, I think, for people to follow sometimes.
Definitely, yeah. And then there's also the control of the product as well. So you may have a product which is designed for an industrial application, and it may be that you've brought in pieces of components or materials into that product, but you don't have control on it. Batteries are a good example. Maybe the enclosure that you're putting it in, maybe there's some electronic components in there that you've bought from distribution network, for example. You don't have the control, but those may be critical elements of that design. And it's absolutely critical that you have control, because if you don't have control and that supplier changes something, they change the material, they change some of the components on the board, and then it's behaving differently. So it may affect the temperature rise testing, it may affect the rigidity for thermal endurance and impact testing, and you have to have that control. And it's stipulated in the requirements as well, isn't it? It's written in the standards. You've got to have, this is the material, and you can demonstrate that you have control in it. And that can throw a lot.
I think a lot of people get confused about the level of specification on things like diodes and xenodiodes for intrinsic safety, where you're tying people down to particular types by particular manufacturers. And that's, normally people are used to be able to swap and change those components around. But as soon as you get into the weird world of explosive atmospheres, it's not necessarily the case. And so it can alter the way in people's design processes works internally.
Yeah, it can really throw people out. Then there's the markings. We laugh quite heartily because the markings are interesting. Where do you start with markings?
Well, space. Normally, the first thing people who haven't done this before say is, where am I going to get the space to put a certification mark for ATEX, one for UKEX, one for IECEX, when my rating label's already full? So there's just a simple real estate issue. And then understanding the specifics of the marking and how important those markings are to the end user, which is really, it's a different concept. The end user is looking at the markings on a product and determining whether it's suitable to use in an environment or not.
It's a big difference between an industrial product and an EX product, and it's the durability and the legibility of the markings, as well as understanding what the markings actually are in the first place, and then controlling it. It's it's a whole new area if you've never done it.
Yeah.
Definitely.
And of course, factory inspection for ATEX as well is if you're doing most of the CE marking directives for electrotechnical equipment, so low voltage EMC, there's no follow-on factory inspection. Whereas, of course, for ATEX, that becomes part of it. So not only are you controlling the product design, but the product manufacture and the manufacturing process, the people involved in that process.
I think that's probably another massive piece that's overlooked.
Yeah.
Because, okay, right, now we've got my product certified and, okay, it meets all of the requirements of the standards. Now you've got to manufacture it, and it's the control of that manufacture. You know, I guess it's not a million miles away from ISO 9001. Yep. But it's far enough to be a problem if you're not prepared for it.
Well, it's the last mile, not the first million, isn't it? I think it's the difficult bit.
Yeah, exactly. Yeah. And being aware of that. Again, a lot of these things, it's being aware of what those issues are or can be, and being prepared for them.
Yes. Yeah, and that's why it's a complex issue. It's why people come back and ask questions about ATEX and IECX, because it's an oddity. Unless you do it all the time as your day job, there's so many complications, so many potential ways of tripping up on the process, which is complicated. And we've talked about ATEX and IECX, which we've said is difficult enough, but we can complicate it further, because what happens if I come to you as a manufacturer, say I need ASICs on this for Europe, give me IECX because I'm going to Australia or Singapore, and get halfway through the project, or near enough the testing's finished and doing, and then I come along and say, oh yeah, while you're there, can you do me US and Canada?
Yeah.
Go on.
Oh, well,
we've been there, haven't we, both of us?
But many times, yeah. And again, it's about preparation. It's being aware. If you've got a product and you've now got it certified for Europe, you've got ATEX certification, then you come and go, all right, now I want US and Canada. Yeah. It's another market, it's another set of requirements, new standards, new tests that are needed, or different parameters in tests. I know it's one of those things, it's easy in hindsight, but being aware of what you are planning for that product, or the markets that you're planning for that product to go to, it's much better to know at the beginning. Yeah,
so it's better to start when you start and say it's ATEX, IECX, and perhaps North America as well, and then you can devise a test plan, I presume, to be able to adapt to all of that.
Yeah, definitely. I think making that decision early on, and not necessarily going for the certification for the US and Canada or wherever else, but at least considering it, because then if we're considering that it may in some stage in its life cycle later on going for the US and Canada, then we can incorporate that into the test plan, and we can make sure that the test parameters, not just for the IEC standards and the EN standards for Europe and international, are covered, but also cover them for the US and Canada. So if you take explosion proof as an example, if we're aware at that early stage that there may be a need to do certification for the US and Canada, maybe in 1 or 2 years' time, what we can do is we can then build the test plan and make sure that we do all of that explosion testing around those parameters. And it doesn't take too much effort, because we're just extending the time a little bit more. We're doing a little bit more testing, different gas groups, maybe we're trying it with conduit, maybe we're doing it at different temperatures, but we can incorporate all of that in at the beginning. And it just means that we don't have to come back into the lab, reset everything up.
Well, effectively, it's a complete retest. If you have to come back for the additional time, if you do it all at once, if you have to come back a year later, you're starting again.
Yeah.
Because you've got to reset everything, recalibrate everything, get the test setup to work. So yeah, it is. And I think that the UL 1203 is a really good example where you can make massive savings just by planning ahead.
The other thing is, well, you don't want to be retesting if you don't have to. You know, you might get some good results on the first go round. Something might happen on the second go round, and you get a failure, and then that's a whole world of pain that you've got to go through and try and unpick and find out what's happened. And retesting's always.
And also, if you do the IEC ATEX standards first, and then you do the UL standard, and the product fails the UL test, but you desperately need to get into the US or Canadian market, it's a complete redesign. So you have to do all the IEC and ATEX testing again anyway on the new design.
Yeah.
Painful.
Yeah,
it's painful.
Yeah. But I'm also just thinking, not only that, but because of the requirements being different, you may end up with different versions of that product. So, for example, you know, we do all the testing together. So we do the EN and IEC standards, and then we cover the UL or CSA standards for US and Canada. And let's say we do get a failure on those US and Canadian standards. You do have a product that goes to market for under the NIC standards, but it might be then you go away, okay, I maybe need to redesign the products. It might be that you end up having two, because I've come across this in the past where, because the seal requirements were different, then we had one seal that the manufacturer's using for Europe, and a different seal material that was being used for North America, and that might be the only viable solution, but at least you've found that out at the beginning. You're not thinking you're going straight into the North American market, and then it's a showstopper, isn't it? It just means that you were thinking it was going to be 3 or 6 months to get into the North American market. Now it's just set you back in your 18 months. Obviously that can be catastrophic to a product launch. Well,
it's true. In conformity assessment, time is money. That's the key thing. The longer you take to get your certificate, the shorter the time you've got to sell things in the market, and deadlines get missed. So time is really, really the most important thing. Yeah.
We were talking about factory inspections and the quality assurance for ATEX, but it is different for North America as well. So, and this is something which is often misunderstood as well. I mean, we're talking about explosive atmospheres, so we're talking about hazardous locations for North America, where factory inspections are quarterly.
Every 13 weeks. Quarterly doesn't sound too bad. But how many customers have said, "What do you mean? You've only just been left the factory, and now you're organising to come back again." Of course, for ATEX and IECX, for someone with ISO 9001, it's once every 18 months. There's a huge difference between once every 18 months and once every 13 weeks. It's a big undertaking for people to commit to in time and in cost. And a slightly different process as well, isn't it, between the two?
And that can be a bit of a shock. If that's not known when you embark upon this certification journey, and you find out at the end, I've got to do this. That's not a pleasant thing to find out. No.
And also the focus of the factory inspection is different. There's the ATEX IECX route is very quality system focused. It's ISO 9001 based plus product inspection, whereas the North American system is the other way around. It's primarily product inspection supported by some quality assurance. So it's not even the same inspection. So you could be doing ATEX IECX factory quality assurance notifications, quality assurance reports, and then it will be very different than when they come in and start doing UL or CSA inspections as well. And people need awareness of that at an early stage before they've got people coming through the door.
Yeah, definitely. And there are other areas as well. We've obviously just spoke about North America, but there's other regions of the world where there are different requirements, and it's an understanding of that, and we issued a white paper on that not so long ago, and looking at the different regions of the world and the different requirements that exist within them, and hopefully people will get a chance to read that and have a look at some of that guidance in just as an introduction to some of the different requirements that exist, and just an awareness, really.
It was really useful, actually, the guide, because it covers all those basics. So whether it's for people who are totally new to EX, or whether the person we're talking to is used to dealing with EX, but they're having to deal with their manager, or perhaps the sales team, or the procurement team, just having that understanding of the complex world of EX is useful. So it's a really good paper, well worth downloading.
Yeah, good. Yeah. So do people understand? Where do we help?
Well, that's always the question. I mean, sometimes the wise customers come in and say, "Here's my product, help." That's the first thing, rather than trying to tell us what to do. So I think that's useful, isn't it? If people come with the expectation that come for advice as part of engaging in the process, that improves their understanding. Talk to experts early, and that in itself's not necessarily be expensive. You can engage as part of the quoting process and the sort of pre-test side of things, where you're thinking about what am I going to bring for test, and actually the best customers are the people who talk to you. Sometimes the worst customers are the ones who turn up day one of testing and they haven't got what you thought because they just didn't ask. You assume that they knew, they assume that you would ask, but because we haven't engaged. So engagement early on, as in with all conformity assessments, so important. Yeah,
and understanding what it is that you need to achieve, and that before starting the certification process, but making sure you know what documentation you need, what samples you need, data sheets and so on, and preparing for the certification, getting us involved as early as possible. I know that's not always possible, and the example that we gave at the beginning about an industrial product, that's probably not part of the R&D process. No. This is coming at the latter stages.
It's opportunist. It's an opportunist sales opportunity, but because of course it's very high value EX product. So actually, if you can sell an EX version, it is tempting. It's a good route to go down, providing you're prepared for the work that needs to go in it. I think that's the important thing from what we're talking about today, isn't it? It's preparation, expectation, understanding what it's all about, really.
Yeah. And also, I think on that last point as well, just the markets. So if you're going to go through the process of getting the certification for the different markets, what's the value of that market versus the cost of actually getting that certification and maintaining that certification?
Yes.
So it's important to do your homework.
We've not really talked about the technical standards, because there's a session on each one of those in itself. But what can people do to find out more about the specifics of standards? Is the things that Element can offer to help with that?
Well, I'm actually preparing another paper which will be looking at standards.
Right, okay.
And looking at the standards in different regions of the world. So really supplementary to my previous paper.
Right, okay.
Where we look at the standards that are used for the demonstration of compliance.
Yeah.
So looking at the IEC, looking at what we have in Europe and what we have in North America, and just getting an overview, not going into the detail of what's written into the standards, but at least an overview of what the standards are and an understanding of, in North America, these are the sets of standards. How do they differ on a high level? How do they differ from, let's say, the standards that are used in Europe? And I think what we'll perhaps have to do is go into a bit more detail in those technical requirements as well. So that's something that we'll be planning on doing in the future, and maybe have a discussion around those points at a later date too.
Oh, it'd be good. I think it's useful. It's useful, and like all again, things conformity assessment, you have to get that high level view, and then you have to keep digging a little bit deeper along the bits that are very specific to you from there. But I think it's a good start today in what we've talked about in terms of the sort of general process, the differences and the similarities. So hopefully people have found that useful, and I'll help you get started. So thank you for joining us for this, and do look out for the next sessions on going into more detail. So thank you very much. Thank you, Andy.
Thank you.